The second half of the climate discussion in week 7 in chapter 13 is global climate change. Is the climate changing and at what rate? What's causing it? That discussion gets pretty broad, and I could have plenty of separate videos on different topics. So in lieu of doing that, I'm going to save that discussion for the book and for the forums. That being said, just a couple of things to touch on. Basic principles whenever you're approaching a global climate change discussion or arguments or forums is to understand the baseline fundamentals of what's going on in the atmosphere to cause this discussion to even take place. The greenhouse effect is a good thing for Earth. Remember that. That is what keeps Earth's temperature stable. Those greenhouse gases that are in the atmosphere help trap that heat, that outgoing long-wave radiation from Earth, and it keeps it from escaping into space, and that those greenhouse gases help trap that heat in the atmosphere, and thereby stabilizing Earth's temperature from getting too cold. The interesting thing about that is the greenhouse gases make up a very, very small percentage of the atmosphere. For instance, the major components, the major greenhouse gases of CO2, carbon dioxide, and water vapor, together make up less than 4%. In actual amounts, carbon dioxide is actually 0.04%, only about 400 parts per million or so in the atmosphere. So it's pretty small amount, 0.04%. Water vapor is also a greenhouse gas, and it is a significant greenhouse gas. It can vary from 0 to 4%, so it's hard to get a handle on exactly the full contribution in any one particular area because it can change so much. So carbon dioxide is a great example. If only 0.04% of the composition of the atmosphere is responsible for a good portion of the greenhouse gas, of the greenhouse effect in keeping us warm, what do you think a small contribution, a small addition to the CO2 would cause on the greenhouse effect? Do you think that would increase it? Logically, it seems so. A very small percentage of the CO2 in the atmosphere is responsible for keeping the Earth warm. So if you increase that very small amount already by a little bit more, you're going to amplify that effect. And that's the logic behind the greenhouse effect in, the global warming and global climate change, is if you increase the greenhouse gases like CO2, you're amplifying that effect because that gas, even though it's very small percentage-wise in the atmosphere, is contributing a very big deal to the greenhouse effect in keeping us warm in the first place. So understanding principle, that's a fundamental argument, a fundamental logic behind global climate change and whether or not humans are involved in it. So let's also talk about where we go from there. Why this argument, why is this discussion of global climate change actually happening now? The whole discussion on global climate change and global warming started with measurements of CO2 rising in Hawaii. The fact that the CO2 levels were rising went back to that logic I just went through, that if we have CO2 levels rising, which is a greenhouse gas, we should see temperature that is rising. We've actually now observed that. That is a pretty established fact. It's a very established fact, let me put it that way, that we have observed over the past 30 or so years significant rises in the global temperature. So is that significant or is that not? That's a different question. But realize that it is a fact. We have observed rising temperatures across the globe. The question then remains, is that something that humans are influencing? Is that something that is natural in the climate system? What is going on? That is still a relevant, perhaps, discussion. But understand that it is absolutely fact that we have observed rising global temperatures. So there's no doubt that there's this rising trend in temperature across the globe, on average. The question remains, is it natural, or is it something that humans are forcing via introducing more greenhouse gases into the atmosphere? There's absolutely no doubt that there is natural variability in the climate system. Absolutely no doubt. On the long scale, there's orbital cycles that change the climate system of Earth. There are short-term impacts that can change the climate of Earth, such as volcanoes. The problem, even sunspot activity, the rate of output of the sun can change the climate system of Earth. The problem is what we've observed, and at least what we know of the climate system, the natural variability that is built into Earth's atmosphere, climate system, and sun interaction. What we know of that no longer explains the increase in temperature in Earth. So we can kind of apply, meteorologists, climatologists can apply what are called forcings on the atmosphere. The natural variability of those forcings we can apply to the atmosphere via models. And those models can then give a forecast or give an indication of how things are going. And there's a lot of error in those models, absolutely no doubt. But the problem is the natural variability that we would expect, and again, that we understand in the atmosphere, no longer explains or let me flip this around. The temperature increase that we see is no longer within the bounds of the natural variability that we understand. So models predict a certain amount of variability in the atmosphere temperature-wise, and we're observing something that's beyond those bounds of natural variability. So we either don't understand something that's going on in the natural system, or there's something in the background behind the natural system that is forcing it beyond the natural bound. And so that's the argument between natural climate change and anthropogenic or man-made climate change. Another argument and another reason why these trends, understanding what that trend is difficult, is whether or not these are cyclical climate system, cyclical climate signals, or if it's an ongoing and irreversible trend. For instance, a lot of people argue that we are just seeing an increase in temperature from the very cold period that the world experienced in the 1700s. You look in historical records and period of the Revolutionary War into even the early 1800s was extremely cold, had extremely harsh winters. And all we're seeing now in the early 2000s, late 1900s, was just that we're getting back to normal from that cold climate system at that time. Quite possible. The flip side of that is, what if this is an irreversible trend, meaning that the trend is still going to keep going up? It may have done this before, but now is it an irreversible trend? And that's the danger, and that's the argument behind an anthropogenic forced climate change. Climate change science is still an ongoing. It's kind of an ongoing science, ongoing and developing a field. It's kind of the baby in the field of atmospheric science. So we have a lot to learn. And there's quite a bit of unknowns, quite a bit of unknowns. Some of the unknowns that we don't know are the responses of the atmosphere given a rising temperature profile, or giving a rising average temperature. For instance, we really don't have a good handle of how clouds are going to respond. If clouds respond in abundance because of increasing water vapor content in the atmosphere because of warming temperatures, then the overall temperature of Earth becomes stabilized because clouds would basically shade us from the sun, and so we would cool off. So knowing those responses would be helpful. Unfortunately, we don't have a good handle on exactly how clouds, for instance, are going to cause a feedback into the climate system. And those feedbacks are extremely important. There's a couple of feedback mechanisms, especially the positive feedback mechanisms, and then understanding how the negative feedback mechanisms act on those positive feedback mechanisms would really help us know what's going on. Let me explain. A positive feedback mechanism is something that amplifies itself. So a human analogy would be something like this. Let's say you're a parent and your teenager is being a little rude to you, so you make a little smart remark back. And so they make a little smart remark back, and then you get a little bit higher in tone, and so they got a little bit higher in tone, and then you start yelling at them, and they start yelling back at you, and eventually you have a yelling match that just amplifies and amplifies and amplifies. That is a positive feedback. That is a positive feedback mechanism in the Earth system. A positive feedback mechanism that is very important is the water vapor positive feedback. What happens when you get a warmer air mass coming in? You get you can hold more water vapor in that warmer air. If the world's average temperature is increasing, that means the world's average capacity of holding water vapor is also increasing. Water vapor is a greenhouse gas. So if you can hold more greenhouse gas inside your planetary system, that means you've got the potential to hold more heat in, which means you can amplify your heating. If you amplify your heating, or you're increasing your temperature more, that means you can hold more water vapor in your climate system. If you can hold more water vapor in your climate system, in your atmosphere, that means you can potentially hold more heat in and raise your average temperature some more. If you raise your average temperature some more, then you can hold more water vapor in the air, which is a greenhouse gas, which amplifies your temperature more, and the process continues. The planet Venus is a runaway greenhouse effect because of this exact same process. It is a positive feedback that got out of control, and then it is that's why it's so much warmer than Earth. It's a out of control greenhouse atmosphere. So the Earth isn't going to ever go like that, but just understand that those positive feedback mechanisms, understanding those will help us understand exactly where the Earth's climate system in the future might go. Of course, there's negative feedback mechanisms also, and we don't know how those would respond. One of the biggest negative feedback mechanisms is the biofeedback mechanism. If you heat your Earth up and you put more CO2 into the atmosphere, your biosphere, or your plants, would respond positively, because more CO2 is more basically fuel for them. A warmer atmosphere gives a longer growing season, and so plants uptake CO2, and they also, if you have more greenery, you can also help to reduce potential heating. So basically the carbon dioxide sink is the biggest one. So if you have more plants, you can sink the amount of CO2 in the atmosphere, which would potentially stop any potential warming due to increased greenhouse gases in the atmosphere. So there's positive feedback mechanisms, there's negative feedback mechanisms. Understanding what role those play in the climate system in the future are things that we still are trying to understand. So there's plenty of work to do, there's plenty of understanding left to figure out. And there's certainly plenty of opinion out there. So I definitely want to hear about your opinion, and let me know where you're at, and I look forward to interacting with you guys in the forums.